Hello, this is Jeans from AGHAMALAYAN. Today we are going to solve this problem involving inclines. Don't hesitate to pause the video if you want to solve it. We are given an angle and a mass. We know certainly that the problem asks for acceleration, so we are going to use the second law of motion. Now, since the person is on an inclined plane, we will rotate our axis. So how do you uh, draw the free body diagram of this one? So I'd like to draw first the angle, like this one. Okay. And this will be your x, and here will be your y. So we know for sure that there is normal force present because it is on a surface, and this will be 30 degrees. The weight moves downward. Okay, this is the weight. Now we now see a right triangle over here, and the theorem for right triangles is that, or in any other triangle, is that its angles, when you add all of them, will be equal to 180 degrees. So 30 degrees plus 90 degrees equals 120 degrees. 180 minus 120, it will be equal to 60 degrees. Now we know for sure that there's that one over there, and this in itself looks like a right triangle. So in here, 60 and 90 degrees, so 90 minus 60 equals 30 degrees. So that is our free body diagram for this problem. But I don't want to look at it that way, since I want to determine the components of my forces easily. So I'd rather look at it in a simplified manner. Now the x component of the weight will be what? So using the trigonometric identities, we are sure that the weight, the wx, will be equal to w times sine 30 degrees. Okay, so wx equals w sine 30 degrees, and our y component will be equal to w, what identity. So this is your y, and we now sure that using SOHCAHTOA we will use the cosine 30 degrees. Now we are ready to use the more simplified version of this one to be able to determine the x and y components easily for the summation of forces that we will do later on. Now in the y component, we have what? We have the normal force, and of course the y component of the weight. So this is wy. This is frictionless, so we don't need to concern ourselves with the friction. And since the wy and it's moving downward, so the direction of your x component will be this way. So we're gonna write it like this. Now we know for sure that the normal force and the y component of the weight is not moving, it's constant. However, this is the one that moves, so we are going to look at the summation of the x-axis. So f net x equals ma, okay, that is the second law of motion. Now the Summation of forces at the x-axis will be what? Wx equals ma. Now wx, we will use this a and a. Now since we're asked for the person's acceleration, so we're going to solve for a. So a, wait, a equals w sine 30 degrees divided by m. Let me delete first some space. So we already used this one, so we will delete this one. Wait a minute. Okay, so we're going to continue our calculations over here. Okay, so a equals, the weight is mass times gravitational constant, so 50 kilograms times 9.81 ms squared, m of ampere squared, sine 30 degrees, all over 50 kilograms. So we will cancel the 50s over there. Now we are left with 9.81 ms squared sine 30 degrees. Now multiplying that one, we will have 4.905 meters per second squared. So here's your answer.